I just finished my first class as a master's student at Georgia Tech studying computer science. The class was video game design. Today I'm going to be going over the final project that I submitted for the class, a Unity video game called Chrono Gauntlet. The core philosophy of this course was studying what made a game feel like a game, what requirements needed to be met to have a true game feel game experience. The working definition for a game feel game is real-time control of virtual objects in a simulated space with interactions emphasized by polish. Real-time control, simulated space, and polish. Playing a proper game feel game should provide a high sensation of control and continuous pleasure from learning and mastering skills, extending the user's senses and immersing them in a playable character within this virtual realm. So as students of this course, this is the core philosophy that we were bound to, but it doesn't mean that we were free to do whatever we wanted. We had two major constraints that we must follow. The game could not be 2D and it could not be an FPS. But having these constraints were important. We may not have been able to make the project that we wanted to make, but we were being guided towards making the project that we needed to make to truly understand all the intricacies that go into making a proper video game. So let's talk about So I tried to think back to my childhood about video games in my past that really exemplified this trait of being a game feel game, and two came to mind, Ratchet & Clank and Jak and Daxter. Both of them had fast-paced combat, fun and exciting visuals, quirky art styles and locations, exaggerated movement, and easy to pick up controls. All of this combined was meant to satisfy the player's senses, which made it very appealing and addicting in that way. So based off Jak and Daxter and Ratchet & Clank, I now had some ideas of where I wanted to move in terms of art style and the movement of the player character, as well as even the combat. But I needed something more for the game, some sort of gimmick that would give it a little bit more of a unique feeling. To find this gimmick, I started trying to think of more modern examples of game feel type games, and there's no better example of that or meets the criteria of a game feel game than Zelda Breath of the Wild. Now my game, can't attempt to match the scope of Zelda Breath of the Wild, but if there's one part of that game that maybe we could fit into this Unity project would be the puzzles. So I decided that my game would involve a combination of fast-paced combat as well as puzzle solving. But I was looking for a way to tie the two together to make the player seamlessly transition between both combat and puzzle solving. This would give the project a unique gameplay loop as well as condensing some of my workload because I could create features that worked for both the fast-paced combat and the puzzle solving. My solution for this was based in the movement. I decided to extend the player's movement abilities from simply walking or running and jumping to add a double jump and a dash. This way the player could feel some sense of progression in the skills that were available to them to use, as well as having a mechanic that could help them both in combat and in puzzle solving, specifically movement-based puzzles where maybe some platforming is involved. With that, the core idea of the game was laid out. After that, it was just about slapping a simple story about saving reality from evil, splitting up the game into interesting arenas, adding a timer and extraction mechanic, and it was pretty much ready to go into development. So let's start with the player character. So here we are in VS Code. We're taking a look at the different scripts that exist for the game logic, and we'll start with the player scripts. So initially we have this dash trail class here, and this is for the effects that will appear behind the player or below the player when they do a dash or double jump. And I won't go through it too much, but essentially every time the user presses the associated key, we're going to go ahead and start a coroutine to activate this trail here, and we're going to go ahead and render the sort of that ghost-like appearance in a different color depending on whether they're dashing or jumping behind the character. And we'll also do that multiple times, just taking the exact sort of position of the player game object and all of its sub-objects and using that to fill out this sort of apparition. Moving below that, we have our laser shot behavior class, and this just defines some basic behavior for the laser that is shot by the player. Specifically, has it reached its target and should it explode? So we have an explode method here. and then I'll go ahead and call the destroy to get rid of that laser, and it also play the explosion sound. I'm not sure if it also does the animation. Yes, it does set off the animation as well. Next up, we have the muzzle follow pointer class. Now this class is make sure that the muzzle component of the player always follows the user's mouse. In this case, the muzzle on the player is the head of the player, so this ensures that the player's the robot's head is always looking in the direction that the laser is pointing at, that's coming out of its eye, and the player's head will look in that direction, and the body doesn't have to be facing it exactly, but the head will make sure that it's aiming exactly where the laser is pointing. Next up, we have the player camera controller. This just controls the camera that sits above the player, make sure that the camera is moving properly and at the correct distance and whatnot. That's all calculated in this late update. Next up, we have the player health tier. This is a pretty simple class. It's just pretty much a bunch of conditional logic that's checking the status of the player. Have they been hit? Should they take damage? What's their damage level at? Do they have a shield? Should they gain health? And depending on all of those events that occur, we'll make sure to update those statuses appropriately. And of course, if the player has run out of hit points, then they should explode. But this will also activate all of the other effects as well, such as should they have a shield around them? Should they lose the shield around them? Should they have sparks flying out of them? Should they have the fire flying out of them, etc. So those are the examples of the damage effects that let the player know that, hey, you're in trouble here. And it also will handle any associated sounds as well. Next up, we have the player look controller, and this is just going to handle exactly where the player is aiming and ensure that the player is rotated in that direction. The player movement controller is pretty much the core of the player. This is probably the most important class that we have, and it being the most important class, it's also the biggest and arguably the most complicated. So obviously there's a lot of properties that are all just keeping track of what is the player doing at this point of time. Are they jumping? Are they walking? Are they double jumping? Are they dashing? Are they doing a combination of both? Are they in water? Are they not in water? So all of this code is just meant to handle that and do all the proper physics calculations, as well as also initiating the proper animations and sounds that need to be associated to all of the different possible movement combinations. It's also important to make sure, is the player on the ground? Have they double jumped? Can they jump again? An interesting problem that had to be solved, actually. Let's see if I can find it here. Yeah, so an interesting problem that had to be solved was we have moving platforms in the final level of the game, and we actually needed to make sure that we were calculating correctly the platform's movement and then also transferring that to the player. So if we weren't doing this code here, then the player would just sort of stay in one coordinate spot, even though we wanted them to move, the player to move with the platform. So that actually has to be calculated, and we actually have to adjust the player's position manually. That's not handled by the physics engine. Finally, we have the ray gun, and this is just the class that handles the actual shooting of the laser. It'll spawn off the laser, what direction it should head in, and also the speed that it should fly. And then quickly I'll go through the rest of the scripts here. So we have our game controller. So this specific end level class just handles, well, okay, what scene or level did the player just complete? Let's go ahead and load the next scene or the next level. This is a standalone sound event. I believe it's just used with the obelisks. Then we actually have our game controller, and this kind of just is the brains of the sort of run time of the game. It's kind of keeping track of all the stats, how many enemies are left, how many pickups are left, what needs to be triggered in the game or in the specific level. Do we need to show a complete screen? Do we need to show a fail panel? Kill counters? Has the player completed the level? Have they completed the game? Should we restart the game? Just a bunch of things like that, all sort of what needs to be calculated surrounding sort of the brains and logic of the gameplay while the player is playing. Then we just have a simple timer script, just all programmatically done. It could have been done not programmatically, but it was just simpler this way, very, very quick and easy to put together. We do have a game menu script. This just handles sort of the logic of the different menus that'll pop up. When should they pop up? When should they be invisible? Make sure to pause the physics and all sort of actions in the game while they are present. If they press a certain button in the menu, should we quit the game, restart it, start the game, show credits, things like that. Also, it allows for specific key binds to also control the menu as well, just with the escape here. Next, we have our pickups folder. This has a class for each of the pickups, and it's pretty simple. It's just saying, is this pickup being picked up? And if it is, let's play a sound. Let's also display a tip message if a tip is being provided. And most of these should pretty much play out the same way. Yeah, so we have our dash, double jump. They're all going to look the same. I think maybe the only one that's slightly different is just with the health pickup. There's some slightly different or simpler logic associated to that because we have to go ahead and make sure that we tell the player to gain health. But in most other cases, we'll go ahead and invoke the game controller. Let the game controller know that a pickup has been picked up. And let's see, anything else here? No. We have some trigger spheres. This is a very simple class. The trigger spheres are used for the puzzles, and basically we want to see, have they been hit by a laser? If so, we should turn it on, and we should remain active for a certain amount of time. We should also play a sound, as well as have some particle effects. I do have a file here, or a folder here, for just some, this was initially, I was building the tutorial level, so I named this tutorial folder because I was using these items just in the tutorial, but then I ended up actually using the tips throughout the game. So this folder should be renamed to tips, but I've kept it, and this is just for the tip behavior. So if a player is has walked over a question mark in the game, we'll go ahead and show the associated tip. This manager acts a lot like the game controller and just sort of handles, well, or more like the game menu, I should say, and just sort of handles the UI that pops up for the tips. Should we close it? Should we show it? Fade it in, fade it out. And then we also have just a quick little tutorial door sound event. This is when I was first working with the sound, and I attached the sound event to a door that's used in the tutorial level. And lastly, we have the waypoint system, and this just calculates, how many enemies are on the map, how many pickups are on the map, is the obelisk on the map, and if so, let's go ahead and create a bunch of arrows that all are constrained to the borders of the window that the player is playing on, and show arrows pointing them in the direction to these different items. And let's make sure that we're associating the correct color to those different waypoints. So that was the logic behind the game, the zeros and ones that made it run. But that's only half the story. Let's talk about the aesthetic. So in this case, I was looking for low poly, clean, simple assets that thematically work together. Number two, I wanted all of the assets to be free. As a student, I didn't want to put too much time or money into finding assets to put into this game, then have the possibility that they wouldn't even work, or that I'd take them out and I ended up spending a bunch of money that I didn't need to. But it also helped constrain me in a good way to kind of force me to think more creatively about what assets I was using, how I was using them. As for the map design, I wanted the player to feel like they were progressing through more and more dangerous arenas. And to signify that, I was using gloomier colors, specifically purple, which I wanted to specifically represent as sort of the source of the evil. So if there was any object in the world that was this purple color, that sort of represented that the origin of this structure or the arena itself is within this evil force that you're fighting. This of course culminates in the third level, which is entirely purple, which sort of represents as like the source of this evil. And the first level starts off on this very simple, beautiful, very calming island, and then you progress more and more through more dangerous territories, and their look is supposed to reflect that. The second level is a quiet forest, clearly once a very peaceful area. The ecosystem can still be heard in the ambient noise. There's a ruin at the edge of the map, and it's supposed to have this sort of peaceful feel that it's been there for a long time, undisturbed until now. As you can tell, that evil forces have invaded this arena, this reality, and a mysterious structure has appeared in the center of this environment, in the center of this forest, that's clearly not of the same origin of the forest. And we can tell that through its purple design. The next world is a tight arena, a battlefield in ruins with a dark and stormy environment. It's clear that whatever existed here before cannot be saved, but the evil forces that have invaded it can still be dealt with. And so finally we reach the third level, the source of this mysterious evil. We can tell this immediately through the ominous undertones of its scenery and its music. All of this is meant to put the player in a heightened state of mind as they traverse the dangerous environment and deal with the many enemies here. Eventually got to the point where the game was ready for playtesting and external feedback. To take the most advantage of this, I put together design questions to pinpoint exactly what I wanted to gain insight from the procedures we would be employing during this phase of development. This included questions that were designed to ask how intuitive the game was, how exciting it was, how difficult, how appealing the maps were, and also how effective the special movement abilities such as the dash and double jump were during combat and puzzle solving. The next step was to create a script to ensure that each playtest session played out the same as the rest. This ensured that each player used the same setup in terms of the build of the game, as well as other technical components, and it was an effort to avoid any sort of outside of variability that could affect the outcome of our data. Once I had this in place, I could actually put together the instruments we would use during the playtesting session. This started off with just a pre-test survey to gauge how much experience the player had with video games in general. After the playtest, there would be a Likert scale questionnaire that would quantify the player's experiences in terms of what within the game worked and didn't work, and this data could be tracked and also visualized. Finally, after everything was completed, we would then provide a play matrix to then quantify what players felt like was the largest influence on their gameplay experience. With that, we could actually bring in the playtesters and perform the sessions, and all of them went very smoothly, and we got a lot of great feedback from them. We were able to quantify the results of the playtest sessions and put them into different charts and other visualization techniques, and able to analyze the sort of raw data received from these playtest sessions. But also important to note that we did have just general feedback, not actual quantifiable data, more just subjective notes that were taken during each of the playtest sessions. And all this combined, we were able to consolidate our efforts and compose a succinct list of action items that we would want to complete moving forward to complete what we felt like would result in a finished game. So some of the items we decided to address were, for example, the water, the effect it has on the player, slowing them down was too jarring, the impact was too great, So we wanted to actually increase the player's speed just a little bit in the water, not have them be quite as slow. And it was also important to make sure that we carry the same effect over to the AI, because currently the AI would not experience that slowdown effect in the water. Novice players also felt that the game was a little difficult to adjust, so it became necessary to create a tutorial level to help those novice players get a better understanding of the controls before we actually threw them into the main levels of the game. It also became clear that an effective means of indicating to the player exactly how much health they had left would be important for the gameplay experience, because at the moment, or before these action items were completed, players could only judge how much health they had by the damage effects that were seen on the robot's body, such as the sparks and the fire, but it was impossible to know unless you had played the game previously and had a game over. You wouldn't have realized beforehand that, oh, fire means you only have one hit left, or sparks means you have 2 hits left. So this was remedied by creating a system of indicators that would actually appear above the robot's head, and the hearts would represent the life points that the player has. But then we were also able to expand this idea and include symbols, indicator symbols for the power-ups as well, and this became a cool little UI feature. Some bugs were also encountered by our playtesters that need to be fixed, such as the mouse disappearing on certain menu screens, as well as the waypoint disappearing on the bottom of the screen. So players would actually potentially miss important objective items if they had walked too far past it, so that was necessary to fix. It was also noted by our playtesters that the dash and double jump abilities rated high on the excitement scale, but relatively low on the utility scale. So the solution to this was to really emphasize their use of the special movement abilities, not only in puzzle solving, but also in the combat as well. We also had an interesting dichotomy where some players found the puzzles too challenging while other players found them too easy, which raises interesting questions. To sort of have an in-between solution for this, we wanted to make the puzzles more complex while also providing more context as to how to solve them. With these fixes, it was time for the final touches and release. The game was officially where it needed to be for a final release as our final project for this course. But the core foundation was there, and I learned a lot along the way. We can see that the demo was purely a proof of concept, only showing off some of the basic mechanics, such as the movement abilities and the pickups. The alpha version introduced the first map, the player character, the enemies, as well as the early puzzle design. But it was missing a lot, specifically in the areas of the audio design, as well as the player's indicator. Finally, we have the release version, which brought everything together. It greatly expanded upon as well as improved the alpha version. There were definitely some big ticket items that never made the cut in any of the versions of the game. You can see here in our presentation some of these items. These were just not feasible to include in our development cycle, but would certainly be interesting to revisit in the future. So thank you for checking out this video of my development for this video game design class as a part of Georgia Tech's OMSCS program. If you enjoyed this video or learned anything from it as well, please subscribe, like the video, and comment. I'm very available to discussing all topics computer science related. And please take a look at the rest of my channel. I have a couple other videos just like this going over some of the other projects that I've built.